Hi, in this lecture we will solve one more question which is of the type 2. Type 2 questions are those questions with data that directly relates to the diameter. Design a pair of spur gear to transmit 24 kW at 1000 rpm to a parallel shaft at 400 rpm. Center distance is 175 mm. So this is a question with minimum amount of data. So usually for a question like this we are supposed to go for more assumptions because of the limited amount of data that is provided. Now based upon the data that is available, we can calculate the gear ratio I using 1000 and 400 as 2.5. Now they have given another data which is nothing but the center distance is 175 mm. Center distance or velocity can be used to find out the value of diameter, because for the velocity the equation is pi dn by 1000, and for center distance we have the equation d1 plus d2 by 2. So upon substituting d2 in terms of d1 by using the gear ratio, we can get the value of d2 as 250 mm and d1 as 100 mm. So this is how we can directly calculate the value of d2 and d1. Sometimes they can give you either the value of d1 or d2. If velocity is given also, we can find the value of d1 and thereafter d2, or d2 thereafter d1. So such kind of questions comes under the type 2 category. Now we have the values of diameter, and the value which is not provided us is the number of teeth. Here we have to understand the procedure very clearly, because we have to find out the weaker member. So in order to find out the weaker member, because that is the first step, so in order to find out the weaker member, we should have the value of stress and the Lewis form factor. Lewis form factor is the one which is calculated using the number of teeth, because in order to have the value of Lewis form factor you need number of teeth. But in this question the number of teeth is completely missing. No data is provided, but without which we cannot move forward. So initially we are going to assume the number of teeth temporarily to identify the weaker member. So the sole purpose is just to identify the weaker member. Okay, so this is an option, one option. So I have assumed Z1 as 21 and Z2 I am going to get it as 53. And finally we have to look into the problem. Now see, to solve a question like this we have got two options. I will explain the second option first and then I will go for the first option, because the second option that is listed here is somewhat same as that of the previous question that we have solved, where I have assumed the material for the pinion and gear as cast steel and cast iron, and I have taken the value of 135.5 and 78.5 from the table. Then I calculate the value of y. There can be a change in the value of y2. Kindly cross check with the data handbook. Anyway, I can calculate the value of y, I can multiply these two together and I can get the value of gear as 8.87, and that can be considered as weaker if I am going to assume like that, assuming the material. This is one option. Second option is that I can assume that both the pinion and gear is made of the same material. If I make an assumption like that, then obviously the pinion is going to be weaker. So I can directly go with the design for the pinion. I am going with the option number 1 because that reduces the labor. You may get confused regarding the option 2, because here if I go with two different type of material, gear is considered as a weaker and here I have to consider the pinion. It is just because of the change of the material. So here I am using the same material, here is a different thing. That is the only thing. Don't worry about the output, because the output you are going to get is purely based upon the material that we use. So in this question I will solve for the pinion. Now we have to find out the velocity. because D is directly available, D1 N1 by 1000. So the value of velocity is going to be 5.23 meter per second. And in the similar fashion, we will assume the value of CS, because they have not given anything regarding the operating condition or the working hours or the working condition. Nothing is specified in the question. So for CS, we will make some assumptions like heavy shock intermittent condition and get the value of CS as 1.5. You can take any value from that particular table, 12.8. So using all this value, we have to calculate FT. P is readily available with us, CS is available, V are available, every value is available, and the value of FT is going to be obtained as 6883 Newton. But in the previous question it was in terms of M. That is a difference. You have to understand, because when we solve problems with type 1, FT was obtained in terms of module, and in step 2 FT was obtained in as a whole number. Now comes the tangential module. Tangential load using the, not the tangential module, tangential load using the Lewis equation. The same equation we are going to use, pi sigma B by M CV. Sigma we are going to use for the weaker member, which is 138.5. That means I have assumed that pinion and gear is made of the same material, and that is nothing but cast steel, like the previous question. And now phase width, as always, 10 module. M is available here. CV is purely based upon the velocity, because right now we have the velocity with us. There is no need to go for the trial and error method. From using the velocity, I can calculate the value of CV. So in this equation we have the value of CV, B sigma, B in terms of module, sigma we have, and FT we have. Now comes the value of Y. The equation of Y is nothing but 0.154 minus 0.912 divided by Z1. But we don't have the value of Z1. Even though we have assumed a value for Z1, that was just for the calculation of weaker member. We will not use that particular value further. So you don't have the value of Z. Since Z is not available, you are supposed to substitute the value of Z in terms of module. So D by Z is M. So Z is going to be D by M. D we have the value as 100, and upon substituting all these values in this Lewis equation, I am going to get a cubical equation. I have to solve this equation, I have to expand this equation, and I have to group this, and I will get a cubic equation like this. And when solving the cubic equation, the possible real root, sometimes you may be having 3 possible positive roots. Among that, one can be selected, one possible realistic value can be selected as the module. So the realistic solution, one of the solution was 6.93, and we don't have a module 6.93, so I standardize it to 8. We don't have a module 7. Kindly go to the particular table for the standardization of the module. So the module I have selected is 8. So using this module 8, now we can calculate the value of Z1 and Z2, 12 and 30. This is the value of Z1 and Z2. Since we have rounded off the value of Z1 and Z2, we are supposed to find out the actual diameters. Previously it was 100 and something, now it has changed to 96 and 240. It was 100 and 250, now it has changed to 96 and 240. Now comes the second part, where we have to calculate the dimensions. I hope you understand what is the difference in the step number 3 when compared to the type 1 question. So in the step number 4, Ft is available, B is 80, velocity we have all these values in terms of module. Using that particular table, we can calculate the value of physical dimensions of the gear. Now comes the 5th step, where we are going to validate the design by calculating the dynamic load and the wear load. The equation is very same. Ft we have, K3 we have, velocity we have, B we have, only thing is C. C can be obtained using the table. And finally the wear load, we are equating the wear load with the dynamic load. We have calculated the value of K, and using the value of K we will suggest the brittle hardness number. In this case both are supposed to be of same hardness. This is how we carry out the design. Usually the only change or the alternative methods that we have to select is in the initial steps. So here there are many possibilities. Sometimes they can give you the gear material, but they will not give you the number of teeth. If so, you are supposed to assume the number of teeth temporarily and you have to solve using this column. If they have not specified the number of teeth or they haven't specified the material, then it's our choice to select both material as same and we can go ahead with the pinion as a weaker member. This is how we have to interpret the data provided. That is, then only we can easily calculate or complete the design procedure for the spur gear. This is the design problem. So you have to solve the problem by categorizing them into types, type 1 or type 2 problems. Sometimes they can give all these data. Sometimes the number of teeth will be given in the question. Along with that they will give you the center distance. If that is the case, then you have to cope up with all the data, because if you assume some data, the ratios or some values should not change. So we have to make the assumptions like that. So usually when the data becomes more and more, then obviously the complexity is going to increase, because we have to compensate, we have to cope up with all the data. We cannot reject any of the data provided in the question. So using this technique, using this methodology, try to solve number of questions. The most important aim of all these problems are nothing but to make you familiar with the data handbook, to make you familiar with the design procedure, to make you familiarize with the assumptions and all these parameters. So once you are familiar with all these parameters, it is very easy for you to modify the design procedure. Many a time you are supposed to modify the design procedure. In order to do that, you should have a clear-cut idea about each step you have executed, the meaning of each step and all those things. So that's all for today. Thank you. This lecture deals with a problem from the spur gear. Spur gear mainly consists of three types of problem. First type consists of data about the number of teeth. The second type consists of the data about the diameters, center distance, etc. And third type questions are the miscellaneous type of questions. Let us discuss the type 1 question, where the data regarding the number of teeth is provided, or else it can be stated that like the data regarding or any data that helps to find out the diameters are completely missing from this question. Such kind of question comes as the type 1 question. Let us read the question 1. A cast steel pinion having 21 teeth and rotating at 1500 rpm is required to transmit 9 kW of power to a high grade cast iron gear to run at 500 rpm. The teeth is 14.5 degree involute. Design the gear completely. Before moving into the solution, we have to read the question very clearly and understand the data. Upon reading the question, it is clearly mentioned that data about the number of teeth. It is clearly presented before you. Pinion is having 21 number of teeth, and that is stated here. Z1 is stated as 21 here. And also we have given 1500 rpm and 500 rpm. They have not mentioned the 1500 corresponds to which other way, whether it is corresponding to the pinion or it corresponds to the gear. It has not mentioned in the question. So by simply looking into the numerical value, we can understand that this 1500 represents the pinion speed and 500 represents the gear speed. So that data is also provided. And what is the use of this data? It helps us to find out the gear ratio. I is nothing but N1 by N2. Using these two data, we can find out the value of gear ratio I. I is nothing but 3. Now it transmits 9 kilowatt. Power is given as 9 kilowatt, and they have clearly mentioned the material of the gear. One is made up of cast steel, and second one is made up of high grade cast iron. This data is very much important. Cast steel, and the second one is high grade cast iron, because sometimes the gears will be made of different material, sometimes it can be of the same material. We have to discuss all these cases, and which will be discussed along with this solution. Now let us go into the solution. See, this is a type 1 question. As I have told you, type 1 consists of the data about the number of teeth. Here it is given. So we have the value of Z1 as 21, and using this ratio Z2 by Z1 equal to I, we can find out the value of Z2 as 63. Now before going into the procedure, we have to write down the data for the stress value. So this is obtained from the table 12.7, page number 234. So we will go to the page number 234, and we will see what are the values 138.5 and 78.5. These are the values provided. Now let us go to the data book, page number 234, and let us see what is the data provided over there. Page number 234. Yes, this is the page number 234 and the table 12.7. It has given a series of materials and the corresponding allowable static stress. So one is given as high grade cast iron grade 35, high grade value. The value of the sigma D is going to be how much? 78.5. So this is the one value we are going to select. And next one is cast steel. So the value we are going to select is this one. These two are the values we are supposed to select, and that is being written on your solution. This is how you are supposed to select the values. Now most importantly, if they have not given you the data regarding the material of the gear, then you can assume any material which is given in the table. Both can be of the same material also. That is also possible. In the coming question, or one more question we will solve, and in that question I will show you what is the difference between this type 1 and type 2, and how can we go forward if suppose the data regarding the material is not present in the question. All those things will be discussed in the next problem. Now let us move into the first step, which is nothing but the identification of weaker member. I hope you all remember the table which I have specified or prescribed. So in that you have got two rows. First row corresponds to the pinion and second row corresponds to the gear. We are supposed to find out the value of sigma 01 and sigma 02, which we have got from the table 12.7. And now comes we have to calculate the Lewis form factor Y. Lewis form factor Y can be calculated using the equation 12.5c. So let us go to the equation 12.5c. It is right over here, 12.5c. I hope you all can see this. This is the equation 12.5c, and we have got three equations, 12.5c, d and e. For this question they have clearly stated that the gear is 14.5 degree involute. So this is the equation we are supposed to choose. So upon substituting the value of Z1 here, we will get the value of Y1, and substituting Z2 equal to 63, we are going to get the value of Y3. That is the value we have obtained in the solution part. Now let us go to the solution and discuss the other features. Okay, so the Y1 value is going to be 0.0194 and Y2 is going to be 0.113. that we have written it over here. Upon multiplying this, we got the value of sigma naught y equal to 12.65 and 8.87. So among these two, the gear value is going to be lesser, and that is considered as a weaker member. That means we are supposed to go along with the design for the gear. So this is the table that is going to give us or can help us to conclude about the weaker member. Now we have to calculate, before going into the next step, we have to calculate the velocity, because in the step number 2 we have to calculate the tangential tooth load Ft, and that has to be obtained in terms of m. Now equation is 1000 pcs divided by v. So v is the velocity, the equation is pi dn by 1000. This 1000 is given to convert mm into meter, and n has to be in rps. So diameter is unknown in this question, so we are supposed to write the value of velocity in terms of module. So d can be rewritten as m into z. So module is nothing but d by t, so d equal to mz. So upon substituting mz1, sorry, mz2, because we are designing the gear, so it has to be in terms of 2. So the equation can be rewritten as pi mz2 n2 by 1000. So upon substituting the value, we will get the value of velocity as 1.65 m. M is representing module, not meter. So we have obtained the value of velocity in terms of module. Now we will go to the table number 12.8 to get the CS, service factor. So let us go to the table 12.8. The table 12.8 gives us the service factor for various conditions. If you look at the table 12.8, you can have various conditions: steady, light shock, medium shock, heavy shock, 8 to 10 hours per day, intermittent 3 hours per day, continuous 24 hours per day. See, if any data is given regarding or which relates to any of the data given in the table 12.8, we are supposed to select that corresponding value. If nothing is specified, it's your choice to specify a particular loading condition and also the type of service. Based upon this, you can get a value for the CS. And in this question, the value of CS we have obtained is 1.5, assumed that the gear and pinion is subjected to heavy shock with intermittent condition. So CS, upon substituting all these values here, we are going to get the value of Ft in terms of m, and the value is 8185 by m. M is the module. Now in the third step, we are supposed to calculate the tangential module using the Lewis equation, and the Lewis equation is pi sigma b by m cv. So Ft we have already calculated, which is nothing but 8185 m. This is the value of Ft. And now sigma is the static stress for the weaker member, which is nothing but 78.5. Y is the Lewis form factor for the weaker member, which is 0.113. And face width B, I hope you all remember the equation for the B, or the suggestion given in the data handbook, and we have selected B as 10 times the module. So upon substituting all these values, it is directly given here 8185 by m, and if you cross multiply this m over here, m into m, it is going to be m square, and ultimately we are going to get this equation in terms of m cube cv equal to or greater than equal to 29.37, and that is how the value you have to obtain. You have to obtain the entire value in terms of module. I think one module is missing here. We will write it down here. One module has to come here because that value is missing here, into m, that has to come here. That value has to come here. So one more m is there, into m. So totally this m into m square into the cross multiplying m cube CV you are going to get. So I will write it in other words, at m, no, multiply m with this equation. Please don't get confused, because this is the same m which is specified here in the Lewis equation, and I have forgot to add this particular m here. Then only we will get an m cube here, that is missing here. So that has to be added here. So please don't forget that. So upon substituting, you are going to get the equation as m cube CV should be greater than or equal to 29.37. Now comes the most important part. We have to find out the value of module m by using the trial and error method. So for the trial and error method, I will brief the procedure and we will solve it. First we will assume the value of module, then we will calculate the diameter based upon the module. Based upon the diameter we can calculate the value of velocity, and based upon the velocity we can find out the value of CV, and we have to substitute all these values here and have to check whether this particular value or the value on the left hand side crosses the one in the right hand side. So let us start with the assumption of module m equal to 3. So the value of velocity we have already obtained is 1.65 m. So upon substituting, you are going to get the velocity as 4.95. So now let us go to the data handbook and see the equations given for CV. See, velocity factor CV has got equations from 12.6a to 12.6e. So 12.6a, 3.35 by 3.35 plus v, that is the Bratz formula when the velocity is less than 8, and same the velocity, if it is greater than 8 you can go for the to 12.6b. In a similar manner you have got equations for various speed ranges. So this is the value we are going to use to calculate the value of CV. So CV is going to be 0.3812. So substituting m cube CV, the value is going to be 10.29, which is much lesser than 29.37. Similarly, we will assume the value modulus 4 gives the velocity x 6.6, CV as 0.316. Substituting, again we got the value as 20.22, which is still lesser than 29.37. Now in the third trial we will go for the module 5, which gives the velocity as 8.25 and CV as 0.357, and finally the m cube CV is going to be 44.62, which is way beyond 29.37. So the module 5 is suitable for this particular application. This is how we select the value of module or calculate the value of module. Now upon getting the value of module m, we have to standardize using the table 12.2 in the page number 229. In the page number 229 you have got various tables. Yes, this is the table for the diameter pitches, and this is for the module. So the 5 is included in the preferred column. So 5 is an acceptable module for the production. Now once we have completed the first part, I hope you all remember the first part consists of calculating the module. Second part consists of the calculation of dimensions of the gear. So the FT is going to be how much? 8185 divided by 5. That value is going to be 1637 Newton. B is going to be 10 m. So it is going to be 50 mm. And velocity is going to be 8.25. Now we have to go and check two tables to find out the nomenclatures. So in order to find out the nomenclature, you have got two tables, table 12.3 and table 12.4. See, basically this table 12.3 and 12.4 gives the various parameters of the gear in terms of circular pitch, diameter pitch, and in terms of module. You can see it over here. And this table 12.4 has everything given in terms of module. So if you want to calculate the pressure angle, sorry, addendum, dedendum, thickness of the tooth, backlash, outer diameter, approximate filter radius, all these things are given in terms of module. So I have used these tables to calculate the dimensions. So it is clearly the proportion is like m, dedendum is 1.25 m, like this you can get the values of the addendum, dedendum, all those values. I have listed only a few here, but you have to list out all the physical dimensions. And in the third part we are going to validate our design by calculating the dynamic load. Dynamic load, the equation is Ft plus K3V into Cb plus Ft divided by, this is the equation, the big equation. All these values are available with us. Ft, B, K3 is nothing but 20.61. V, everything is available. The only unknown value is C. C is called as the dynamic factor. So in order to find out the dynamic factor, we have to find out the error. Now let us go to the data handbook and see how we'll calculate the error. So this is the figure number 12.5. Right now we have the velocity some 8.25 something. So this is going to be 5, 6, 7, 8, 8.5 something. It is going to come somewhere over here. And we'll take to the left hand side, we can see it is going to be 0.045 in that particular range. That is the value of error. Now using this error we have to move forward, and we have another table which is nothing but the table. This is the table. The table 12 point. We have a table that will give us the error value. Okay, this is the velocity table 12.12. Here you have got three sets for 14.5 degree, 20 degree full depth and 20 degree stub teeth. Now it is going to be 0.045, and we have the material. Based upon the material we have to interpolate between the values, because the value right now we have obtained for the error is 0.045, something like that. And based upon that, since that particular value is not listed here, you have to interpolate using the near ones. So upon substituting all these things, the value we have obtained is what? The error is 0.045 and the value obtained is 340.75 after interpolation. So we have used cast steel combinations, because three combinations are given: cast iron, cast iron steel, and the third one is steel combination. So since the material is directly given in the question, it was easy for us to take the column and corresponding value of C. Upon substituting all these value, we will get the value of FD as 11990. And the final step, we have to calculate the wear load using the equation D1BQK. You have to be very sure that this is D1, this is not D2. In order to calculate the FW, you have to use D1 itself. Now upon substituting D1, we have, which is nothing but 21 into 5, 105. B is 50. Now we have to calculate the value of Q. Q can be calculated using the equation 12.5C, where 2D2 divided by D1 plus D2, 2Z2 divided by Z1 plus Z2. So upon substituting the value of Q, we get the value of Q as 1.5, and that is substituted over here. And the value of FW has to be greater than FD, 11990. So keeping that condition on table, we are keeping K as unknown and find the value of K. So we will equate FW with FD and we will find the value of K, and the value of K obtained is 1.522. Now we have to move into another table. I'll show you that particular table. Yes, this is the table 12.16. So you have the value for 14.5 and 20. So based upon the value of K, we have to find out the corresponding hardness for the pinion and gear. So in this case the value was how much? The value of K was 1.522. The value was 1.522. So 14.5 degree, 1.522, the value that is going to come greater than 1.422 is 1.598. For that corresponding value of the Brinell hardness number is 400 and 350. This is the value of hardness we are going to suggest to the manufacturer in order to have a wear load greater than the dynamic load. This is how we should carry out a design. So all the steps has covered. You have to sit and solve, because it is a lengthy procedure. It will take some time to be used to it. So once again, read all question properly and understand the steps and try to execute the problem. Thank you.